Okay, I want to derive the quadratic formula for you. We start off with the general quadratic ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and of course a is not 0. And we do it with a few little tricks, but you can see how straightforward it is once you see the process. The first thing we want to do is subtract c from both sides. So we end up with ax squared plus bx is equal to negative c. Then we divide both sides by the coefficient of the squared term, the a in other words, and you end up with x squared plus b over ax is equal to minus c over a. Now here comes a little trick. The trick is to turn the left-hand side into a perfect square, and you can do that by taking half of the x coefficient, which would be b over 2a, and squaring that, and adding that quantity to both sides. If you do that, you get x squared plus b over ax. Now we're adding the square of half of that, so b over 2a squared. So it's b squared over the quantity 2a squared, which is 4a squared. And that quantity we add to both sides to keep the equation balanced. Okay, now we can employ our little trick. I said that when I did that, I would get a perfect square on the left. In other words, I can write this trinomial as something, a sum of two things squared. And what that is turns out to be whatever it takes to square to get the first term, so that'd just be x. And then on the other side, the other term is whatever it takes to square to get the third term of the trinomial, so that'd be b over 2a. And because the middle term is positive, there has to be a plus here. Now, if you doubt that this quantity is equal to that quantity, all you have to do is square it back out or multiply it by itself, and you'll see, in fact, that this quantity is equal to that quantity. And if you want to take a minute to convince yourself, you can do that. On the right, we can't add these two fractions unless we get a common denominator. So I need to multiply the top and bottom of this first fraction by 4a, and that'll give me a common denominator of 4a squared. So if I take the numerator and multiply by 4a, I get minus 4ac over 4a squared. And now the second fraction already has the correct denominator. And so what I end up with on the right is, and I'm going to write the positive term first just because it looks better, b squared minus 4ac over 4a squared. Now if I'm skipping too many steps, or if you want to see it in more detail, pause the video and work out the details yourself. Now I want to take the square root of both sides. When I take the square root of this quantity squared, I just get x plus b over 2a. But remember, there's a positive and a negative. So if I ask you what the square root of 4 is, it would be either plus or minus 2. So I end up with plus or minus, and I just take this, to take the square root of a fraction, I take the square root of the top over the square root of the bottom. Now the top is as simple as I can write it, but the square root of 4a squared is simply 2a. Now if I subtract the b over 2a from both sides, I get x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And last but not least, there's already a common denominator, so I can write that a little nicer as minus b plus or minus the square root of b squared minus 4ac all over the quantity 2a. And this result is what we know as the quadratic formula. So if you've never seen it derived, you can now see where it comes from.